Hey everybody. Today we're talking about group summaries in R. Throughout this vid, I'm going to be working with the classic iris dataset that comes built in with R, and I've already pulled up the help file here. You can see that it consists of 150 observations of 3 different species of iris flowers. So on the surface of it, quite an innocuous dataset. If you scan down a little further in the help file, though, you'll notice something a little bit interesting in the sources. In particular, I'm looking at Fisher's original paper from 1936, The Use of Multiple Measurements in Taxonomic Problems, which appeared in the Annals of Eugenics. For me, this is a reminder that in the modern era, even as we seek to outgrow some of the mistakes of our past, we still need to look them in the eye and recognize that a lot of modern statistics and data science has some pretty dark origins. All right, so enough about that. Let's actually get into group summaries with R. The major tool that we're going to be using here is the summarize function. I am spelling it with an American spelling with a Z. If you are using a British spelling with a summarize with an S at the end instead of a Z, that will also work. The summarize command just gives us back summary statistics in the form of a data frame, or a tibble in tidyverse parlance. So first of all, let me make sure I actually load up tidyverse. I have it in my Quarto document, but let's make sure it's actually here in the console as well. So fundamentally, I pass the summarize command the data set of interest first. You'll see I'm doing that with the pipe here, so the pipe is going to pass iris into the summarize command as the first argument. And then after that, we say the summary statistics we want. And you can see the syntax I'm using here. So I'm saying what the name of the column should be, and then how the values should be computed. So this chunk of code is going to give me the average petal length and the standard deviation of petal lengths in this set. There it is. You can see it's a very simple data frame. We have 2 columns with those names that I just specified. Just 1 row because we're getting exactly 1 mean and 1 standard deviation. On its own, it's not a very interesting function. If you just need an average of petal lengths, you probably just use the mean command directly. The summarize command gets more interesting and useful when we use the .by argument to obtain results at the group level. So this next chunk of code, starting in line 26 here, 26, is doing exactly the same thing, but now the computations are going to be done group-wise, according to species. So after I've specified the summary statistics I want to compute, I put a comma, added a new argument, .by. And so now the result is going to have the same columns, those same 2 columns that I just mentioned, but now 3 rows, 1 for each of those different 3 groups. Let me reorganize my windows a little bit so you can see the table a bit more directly. There it is. We have a row for Setosa, Virginica, and versicolor, just like we would hope. Now this syntax I just showed you is fairly new. The .by argument was only added to dplyr, I want to say in 2024 or 2025. Historically, we used a group by and summarize pipeline that I'm illustrating here starting on line 37. And this code chunk is going to do exactly the same thing as the last one I showed. The difference is just that we have split up the group summary into 2 different commands. This has the merit of that each of the functions is doing exactly one thing, and the code is very, very clear. It has the downside of being more verbose and potentially adding clarity where none is really needed. So when you see group by, you're kind of thinking about an Excel spreadsheet that is now going to be colored according to those groups. So maybe I have the versicolors in a light green and the virginicas in a light yellow, something like that. But ultimately, it's really just taste which one you're using here. I will point out that if you just use the group by without a summarize, you really do get the same data frame back, the only difference being that you now have an additional attribute. Groups, in this case species, with 3 levels. So this is R's way of handling that sort of color-coded Excel spreadsheet. Now, one advantage of that older syntax is that it allows you to make groups on the fly. And the .by argument within a summarize does not allow you to do that. So for instance, if I want to do a grouping for my iris data set where I have sort of like longer sepals and shorter sepals, where I might distinguish those two with a cutoff of 6, I can do that here. So I did a group by where I'm saying a group is going to be called long sepal with this logical condition. So it'll either be true or false. And then my group summaries in this next command will happen at that level. And so there you can see the output. You have the long sepal, true and false, and then the other two columns are exactly the same as before. Now, in order to do that with the .by command, you have to do a mutate first. You actually have to add the variable to the data set as a column. So you can see I'm doing that here with a mutate. A bit more technically, what's going on here is that when you're using .by, it's using tidy select syntax, so it wants column names. Whereas the group by command is using data masking, and so we don't necessarily have to have columns that already exist in the data set. Last thing I want to point out here is that regardless of which way that you are doing your grouped summaries, you can group by more than one variable at a time. So for instance, just to use the syntax that I was using in that last chunk with .by, I can get a group summary with these exact same summary statistics, the mean and standard deviation petal length, broken down by both species and whether we have a long sepal or not. So let me execute that, and I will reorganize my windows so you can see the difference a little more clearly as a table. There we go. So now we have 5 rows in our data set. We have every possible combination of species and long sepal that appear within this data set. So we have 3 different groups for species. We have 2 different groups for the variable long sepal. That should give us 6, but you'll see that there are no setosas with long sepals represented here. There are none in the original data set either. Last comment on all this is that when you're using the .by argument within the summarize command like I have been, the result is always an ungrouped set, one without that group's attribute, which I think for the large majority of purposes is the desired behavior. If you're using this somewhat older group by syntax, then every time you use summarize, it strips off one layer of grouping, so things potentially get more complicated if you're grouping by more than one variable. For the most part, I think the .by syntax, where the result is always ungrouped, is easier, but you may have specific applications for which that other behavior with group by is desirable.